Slope-intercept form is a way to write the equation of a line that would normally be graphed on a coordinate plane. It's called slope-intercept form because there is a part that identifies what the slope of the line is, and we use the variable m for that. And then there is a part of the equation that identifies where the line will cross the y-intercept, or what the y-axis, which is the vertical axis on the graph. And that part is used, we use the variable b to represent the y-intercept. Graphically, we've got a graph here of an example of the equation y equals 1/3 x plus 1. Graphically, this means that the y-intercept is 1 and the slope is 1/3. And let me show you where those come into play in the on the graph. I like to say that the B stands for begin, and that's where you start graphing any line. So on the graph, you would begin with the positive 1 on the y-axis, which is approximately right there. We know that the line is going to pass through this point, and then we use the slope to find another point on the line so that we can then graph it. That other point on the line will be found using the slope, which is a direction. So we have a beginning point, which is the y-intercept, and the slope tells us a direction from there to find another place that's also on the line. Since slope is set up as rise over run, in this case 1/3, we rise 1 and we use the run of 3 to find another point that's also going to be on the line. With those 2 points, we can then connect the dots, and we've got a graph of our line. We only ever need 2 dots to graph a line, and those 2 dots are found again from B, telling us where to begin, and that gives us a starting point, and then we use the slope, M, to find a direction to go from there to find another point that's on the line, and we can connect the dots. Let's practice now identifying the slope and the y-intercept from an equation. In A, it's already set up in slope-intercept form. This looks just like y equals mx plus b. And since it's set up that way, it's pretty easy to identify that the slope is 3 and the y-intercept is 4. So when we're asked what the slope is, we'd say 3. When we're asked what the y-intercept is, we'd say 4. In example B, it's not as easy because it's not already set up in y equals mx plus b form, or slope-intercept form. So we're going to need to subtract 3x from both sides to get it that way. So the left side now only has y. The right side should have 2 minus 3x. I can use the commutative property of addition to rearrange that so that it's y equals negative 3x plus 2. Now it's in slope-intercept form, and it should be pretty easy to identify the slope is negative 3 and the y-intercept is positive 2. Some things that may trick you on this, it might be something like an equation that says y equals 2x. Well, the slope is easy to identify as 2, but what is the y-intercept? There's nothing there. Well, we need to remember our invisible numbers. There really is something there. It's a plus 0. So the y-intercept should be 0. Or in other words, it's going to pass through the coordinate plane and pass through the y-axis at the origin. So it is going to go right through the origin when it is graphed. A related idea that might be confusing is, what if you see the equation y equals x plus 7? What is m? Again, an invisible number. This time it's 1. So the slope would be 1 here, and the y-intercept would be 7. Finally, another one that might be a little confusing to you is, what if you see y equals 2? Well, there is no x term. Or is there? Is this not the same thing as y is equal to 0 times x, which is just 0, plus 2? So 2 would be the y-intercept, and 0 is the slope. Meaning this would be a horizontal line that passes through 2 on the y-axis. Just remember that in some cases the equation will not be set up in slope-intercept form for you, so you might need to do some solving steps to make it that way. So if they give us the slope and the y-intercept, we need to again remember that slope is m and y-intercept is b, and they want us to write the equation in slope-intercept form. Well, we just need to substitute those numbers for those letters. So if slope-intercept form is y equals mx plus b, we're going to rewrite the equation where m and b would be numbers, and y and x will still be variables. So y is equal to, in problem 1, 7x plus 4. In problem 2, y equals negative 3x plus 5. And then in problem 3, y equals, I'm not going to write the 1 because it's an understood one when I don't write a coefficient in front of x. And I'm not going to say plus negative 6. That's a unnecessary use of symbols there. I'm just going to say minus 6. Okay, let's take a look at some graphs and see if we can determine what the equation of the line is. In number 7 here, I can tell that the y-intercept is negative 2 because it's shown to me on the graph. That's where it passes through the y-axis. Since I know that, I then know what b is. b is negative 2. Can I tell what the slope is from the graph? Well, this is something we've been practicing in class lately. I can go from one point to the other, and I choose to go from the leftmost point to the rightmost point to determine what that slope is. It looks like I'm going to have a rise of 6 here and a run that is 2. So when I set up my rise over run, which would be 6 over 2, and simplify that, I find out that the slope of this line is 3. Now that I know these two pieces, then I can plug them in, just like I did just a moment ago with the previous problems, and I can write the equation of the line, which should be y equals 3x minus 2. Let's try again on the next problem. In this problem, they didn't tell me what the y-intercept was, but I can identify that it passes through the y-axis at 1. Okay, so I will use b as 1. I need to determine what my slope is, so I'm going to count from one point to the other, again going from left to right. So I've drawn in my rise and run. My rise, it looks like I went down 8, so that's a negative 8, and my run is 2. Because I'm going from left to right, my run should always be positive. Going to the right is positive. So really, it's up to the rise as to whether or not my slope will be a negative or not. In this problem, the rise over run is negative 8 over 2, which simplifies to negative 4. So the equation for my line is y equals negative 4x plus 1. Last problem. Again, in this problem, they have shown me what the y-intercept is. It's 4. So b is 4, and m, for this one, it looks like the rise is 5 units, and the run is 1. And that was up 5, so it's positive. Okay, so I get 5 over 1, which is simply 5. So the equation for my line is y equals 5x plus 4. Okay, the last skill that we need to do is to be able to graph an equation. We're going to kind of work backwards from what we did before. We're going to identify what the slope is. If it's negative 7, that means we're going down 7 units from where we begin. So we begin at 2 in this problem. We're going to go down 7 units and over 1, because this could be rewritten as negative 7 over 1. So down 7 would be 1, 2, 3, 4, 5, 6, 7. That's off my graph. And then over 1 unit, it puts it about right there. And then I would draw my line that goes through those 2 points, which I didn't do very well because I don't have a ruler or something. Let's try the next one. Slope is 5, which is really 5 over 1. So rise is 5, run is 1. And the beginning point, or the y-intercept, is 4. So here is where we would begin. I would go up 5 units and over 1 unit. Well, that's off my graph too, but what is on my graph is down 5 units and left 1 unit, which would make it like negative and negative, negative 5 and negative 1. Those would simplify to the same slope of 5. And that will be on my graph. So I'm going to go down 5 units, 1, 2, 3, 4, 5, and left 1 unit, which is going to put it about right there. So this line would look like this, which again I didn't draw very well, but it's not about drawing, it's about knowing that those points are where they should be. Would you please try problems 20 and 21 for your warm-ups for tomorrow? So please do problem 20 and problem 21 and graph those just on a small graph, and we'll transfer those answers to our warm-ups for tomorrow. Good luck.